next group is Dance Dance Pose. That's going to make it's an app that will make you want to dance dance pose the night away.
Hey everyone, I'm Sean. These are my teammates Jimmy, Paola, and Joe. And together we're the team that developed Dance Dance Pose, the competitive singing and dancing game where users' vocal and rhythmic talents are put to the test against some of their favorite songs. Our application is inspired by games such as Dance Dance Revolution and Rock Band, and when we were initially ideating around ideas to develop, we thought, why not combine the best elements of both of those games? Users who come to our game will be tasked with tapping disco balls to the beat of their selected song and singing on key to increase their score. While users are selecting a song, they can also select a level difficulty, with higher difficulties providing an increased score multiplier. Once the user selects their song and their level difficulty, they'll then be brought into our actual game, where their webcam and microphone will be used to detect their motion and voice. The more disco balls the user taps and the more accurately they sing, the higher score the user will achieve, and if they score enough points, they can add themselves to our leaderboard and live forever in Dance Dance Pose infamy. Now, I'm going to pass it off to Jimmy, who's going to talk more about our voice and pitch detection used in our app.
Thank you, Sean. For the singing piece of our app, we used a web audio context wrapper to give us the ability to simultaneously play music as well as capture sound from the microphone. We have three main singing features. The first feature is karaoke lyrics. Karaoke lyrics are displayed on the screen and highlight as the song progresses. We couldn't use any external API because it didn't serve a use case, so we created our own data to match lyrics with pitch. The second and third features that we had is a pitch tracker with a collision system, along with a pointer to provide feedback. We sample for pitch every 500 milliseconds and compare it to the isolated vocals of the original artist. We disregard any flats, sharps, as well as octaves to be more forgiving to the user to improve the user experience. At the same time, a pointer glides up and down along a colored gradient to provide the user real-time feedback on their pitch, and they can adjust on the fly. One of the greatest challenges about creating this app was timing. Because we had to do real-time web audio detection and processing, we had to tie both our dancing and singing features to the song's current time by doing manual adjustments. Now Paola will talk a little bit more about our motion capture and dancing features.
Thank you, Jimmy. For the dancing part of our game, we generated random coordinates within a defined boundary based on the beats and the times of each song. At the same time, we would track each player's coordinates on the screen using computer vision techniques to know if they match the position of the disco balls at every instant. To achieve this, we use Tensorflow. More specifically, we use Posenet, Google's machine learning algorithm, to estimate human poses in real time. We would basically take a picture from the webcam every 200 milliseconds and run it through a previously trained algorithm that would identify the coordinates of where key body joints are. This allowed our users to hit the disco balls with their wrists, their elbows, or their knees, making the game more dynamic. Because their algorithm is being run in the browser, no pose data ever leaves the user's computer, giving our gamers more confidence on allowing us access to their webcam. However, running such complex processes on the front end forced us to face a trade-off between accuracy and speed. The higher the accuracy on estimating the poses, the slower the image would render on the screen. Now Joe will talk to you about the architecture of our game.
Thank you, Paola. Hello, everyone. My name is Joe. I'm going to introduce you to our game's technical hierarchy. As previously mentioned, we incorporated Posenet and WAD with JavaScript to give our game a strong, dynamic, well-programmed backbone. All our user interfaces were built with the React library. Additionally, we use Redux to store all important information in a single source of truth, easily accessible by all React components. Although our game mostly relied on the front end, we did use SQLize and Postgres to store sensitive data in the back end. In order to time the disco balls with the beat of the music, we utilizes Spotify's API to grab the exact timing of the beats. Additionally, we deployed our app with Heroku, as Firebase's slow latency proved non-optimal for our game's rapid data flow. Travis's continuous integration updated our app throughout the building process. Lastly, with only 2 weeks to spare, we chose pair programming as our agile development strategy to optimize for functionality. If you're interested in singing and dancing your way to the top, please try out Dance Dance Pose. Thank you, everyone.
less inspiring when you don't have the karaoke or the disco pulse. But I'm in the Dance Dance Post spirit anyway.
Awesome.
Yeah.
What a great way to end the full stack New York projects. Well done. It's interesting to me that pose recognition is done entirely off camera, not off like a 3D infrared dot field, and that's how good it was. And then the pitch stuff too. That's something that it's a good solution to, I think, a challenging problem to recognize singing quality. So very cool.
Exactly. And, we've talked about collision detection in a lot of these other apps. Well, in this app, you're doing collision detection on multiple planes across multiple axes, not only visual and spatial, but also in pitch and sound, which is, another problem entirely. And the machine learning in this case, Posenet, they're because of the video and wanting to make it performant, they actually run it in the browser using JavaScript, as you said. Like it used to be that this was not able to be run in the browser, but now through Tensorflow and everything, you can actually use these trained models to do something really fantastic.
Is TensorFlow being compiled down to WebAssembly, or is the model being actually run in JavaScript?
So the model, I believe, is just being used in TensorFlow in JavaScript, because there is a TensorFlow JS now. And so you train the model, and then so Posenet is the model, and then you import it using the JavaScript, and TensorFlow is evaluating that on the front end.
Wow.
Machine learning, yet another exciting frontier paradigm we can interface in with JavaScript.
Yeah.
Amazing stuff.
Yeah, so if you like that, be sure to like it on Facebook, because this is your last chance to like a full stack New York project. So please do that.